Hi, dear student. We continue our lesson from page 60. Okay, today we are going to study about the trends in each group, in each important groups that I've mentioned before, like group 1 and group 7, halogens, and group 8, um, noble gases. Group 1 as is known as alkali metals. They are highly reactive. Uh, the position is here, as you can see on the pictures. Group 1 is included lithium, sodium, potassium, rubidium, cesium, and francium. Um, Because of highly reactivity of these metals, these elements, they are stored in oil to prevent reacting with air. They are so sensitive, even they can react with air. So they are highly reactive. Reactivity is increased from up to down. That means if you move to down, the reactivity getting increased. And all these metal can react with water in aqueous solution, which can produce the alkaline solution. These are alkaline solution like lithium hydroxide or sodium hydroxide. The another production is hydrogen gas. Okay, hydrogen gas can be another production, and because these gas, hydrogen gas, of course it's form of the gas and can leave the system. So when you have a lithium metal and if you put it in the water, they react very strongly, and the rest is lithium hydroxide, the alkaline solution, and the hydrogen gas, which can leave the system. All these metal can react with water. Okay, I said that. And melting point is decreasing if we move from up to down, and density also is increasing. Okay, melting point is decreasing and density is increasing. That you need to keep in your mind and memorize this. And the next one is group 7, which is called halogen. They are poisonous, they are toxic, and they have a strong smell. It's not good for health. And they can be easily get a form of X2. That means chloride or bromide or iodide. That means each two elements or each two atom can make a one molecule. The molecule form of X2, like color can react together and make a Cl2 molecule. The valency or combination power is 1. That means these nonmetals, these halogens, can react with only other one atoms. So that's why the combination power is 1. That means they can receive another one atoms. The reaction with water produce a strong acid, like here, like color can react with water and make two strong acid. This is a strong acid, hydrochloric acid, and another, this is like a weak acid, hypochlorous acid. Okay, this is the reaction between the halogen. This is an example of the halogen. Another halogen like bromide can react with water and produce two other acids like HBr. And they are known as a most reactive nonmetals. Okay, they are kind of nonmetals, but the most reactive. And reactivity, but group 1, if you remember, they are metals, they are not metals. When I said that they are so highly reactive, that means between a whole table and also between metals, but only between non-metals halogens are the most reactive. Reactivity is decreased from up to down in this group, and melting point also increasing slowly from up to down. Boiling point same, increasing slowly from up to down. And another point is combination of the halogen with the other elements called halides, like mm, um, like sodium halides, like potassium halides. But if they combine with the metals, they create a salt or metal halides. We call it metal halides. Like as I said, if they react with the sodium or lithium, we can say lithium chloride or potassium bromide, which totally is kind of salt, and we call metal halides or halides. These halogen atoms can create negative ions, negative form of the ions, just one negative bar, like fluoride, one negative bar, or chloride, one negative bar, and bromide, one negative bar. All are same. And uh, there is one important kind of reaction in this group, which is called displacement reaction of the halogen. As I said, in group, when we move from down to up, reactivity become higher, and like fluor, which is the most reactive, and after that is chlor, and after brom and iode. Iode is the least reaction. For example, if you have a compound like potassium bromide, and one part is potassium, another part is brom, and the reaction with the color here, first you can see that which one is more reactive. Here color, okay, here is brom. So color is more reactive than the brom, which can replace here in this compound. So after the reaction, potassium can be stable at its position, but the color can replace in brom. The brom can leave, okay, color can leave the compounds and make a boron gas. So these two example of the reaction is depends on the reactivity. In this case, the second one, for example, potassium iode, color again is higher reactive than the iode, so the color can replace by iode. So in this case, you can predict the yield or productions which can be stay here, whether these atom can be stay here or replaced with the other halogens. The last one is group 8, or called 0. And sometimes they call it group zero because there is no reactivity, and the properties is very just a few properties because of their uh, non-reactivity. So it's located at the end, at the right hand, at the end of periodic table, and also can be called group 8. They are famous for noble gases because last time ago the scientists who discovered the neon or argon, they awarded the Nobel Prize. That's why after that scientists called noble gases to this group. They are not reactive, and when they are not reactive, so it's easily can be isolated. This is because of the electron arrangement, which last session I told you, because the electron arrangement is very stable, well arranged, so they are not disrupted easily. About the application, helium, here the first one, which is the smallest and lighter. Uh, of course, they are unreactive. It's reactive, so it can be used for airship, like here, as you can see on the picture. Airships and balloons can be used for the fill of the balloon. Argon also is used to fill the light bulbs because it doesn't react with flame at the high temperature. Here the flame which is connected to the power or electricity, but after a while, as we know, it gets very hot. So in high temperature, even argon gas doesn't react with this. So argon gas is stable in these glass bulbs, and so that can keep the light. And another thing, argon is the most common noble gases in air. As we know, the nitrogen and oxygen is the most gases in atmosphere, but among the noble gases, argon is the most common in atmosphere. Neon can be also this second one, can be used for the different colorful light. So because of their electron emission and some other properties, it can produce different color lights. And the last one, the last point is melting point and boiling point are extremely low. It's very low, so that's why like helium cannot be easily become a solid. So they are a form of gas. And yeah, these are for today, and you need to give the answer for question 1, and this is question 2. These are related to uh, our study today. And question number 3, question number 4, and question number 5. But I need to explain you here, this is AR, means the size of elements. The size of element here, they said greater, that means larger or bigger size than bromide. This is this question about the Q2, here Q, which means is it larger or bigger than the bromide, this one, or no. um, if you feel confusing for the question, you can try to read for more details in books and give the answer. That's all for today. Thank you so much.